First thing we're going to do is we're going to find the area of R. So to find the area, we're going to draw a rectangle and find the width and the length of this rectangle. And that will give me the area of this one rectangle. Well, the width is the small change in x, and the length is going to be the top minus the bottom. The top curve being 2x and the bottom curve being the parabola x squared. So my area is going to be the integral from 0 to 2. So finding the antiderivative, I end up with 4/3. So now I'm going to find the volume of the solid that our cross-section perpendicular to the x-axis is this area. So the difference between this and one that we already done is that we don't know what type of shapes. It's just we know what the area is. So if you remember, the volume of a cross-section is always the area of the cross-section times the small change in x. So we don't even have to find the area of the cross-section because it's given to us already. So then I'm going from 0 to 2, so finding the antiderivative. We're going to substitute to 2, and then be careful, substitute to 0, because cosine of 0 does have a value, and it's 1. So I'm going to get 4 pi as my answer. So now for part D, it says, find the volume if the region is revolved around the x-axis. So if the region is revolve the x-axis, I'm going to get a washer. So if you notice, there's this washer area. So I'm going to need the big R and I'm going to need little r. So big R, I'm going to put this, oops. I'm going to move this just a little bit so we can see the washer here. Alright, so here's big R. So big R is the top minus the bottom, so it's going to be 2x minus 0. Little r is the small radius. So the radius is going to be the top, which is x squared, minus the bottom. So my volume is going to be pi r squared, because that's the area of a circle. So it's going to be the radius, the big radius, minus the small radius squared from 0 to 2. So if I take the antiderivative, I end up with 64/15 pi.